Okay. Ionic bonding is when you have a metal and a non-metal. And so that's like when you're looking at the periodic table. And we know we have that little jagged line that separates the metals from the non-metals. Kind of like that. You have your non-metals over here. You have your metals over here. We know that the non-metals are really electronegative. Fluorine right here is the most electronegative atom we have. So metals actually, and this is the least electronegative because they have very few protons per shell. You know, for every shell that they have the fewest protons. Over here, they have the most protons you can have per shell of electrons. So metals are not electronegative, non-metals are. So the metal and the non-metal come together. The non-metal attracting electrons more will actually take electrons from the non-metal, or the non-metal will take electrons from the metal. Since the non-metal is gaining a negative thing, it becomes negative. Since the metal is losing a negative thing, that's like saying minus a -1, the metal becomes positive, and we know opposite charges attract. So positive, negative attract, and they stick together. That's what ionic bonding is. It's the two atoms gaining, losing electrons, so that one ends up being negative, one's positive, and then they stick together to make this ionic bond. You might wonder how we know, like how do you know how many electrons you're going to gain or lose? And the way to figure that out is, well, metals are going to lose their valence electron because there's the most shielding, blocking those valence electrons, and they end up with a full stable shell. They'll end up with 8 electrons in their outer shell. Non-metal electrons will gain electrons to get up to a full stable shell because they can attract. They have less shielding for that one shell they're filling up. So they are more electronegative. They're gaining electrons until that shell's full. They won't gain past that because they'd have too much shielding. I'll show you that in a second. So let's see. Okay, so if we looked at lithium and fluorine, the lithium had the 3 protons, right? And 2 electrons on the first shell, 1 electron on the outer shell. That last electron experiences the most shielding. And if I have fluorine here, fluorine has 9 protons, and it's going to have 2 electrons on the first shell, 7 electrons on the next shell. 1 s 2, 2 s 2, 2p5, right? 1, 2, 3, 4, 5, 6, 7. Okay, so it actually has space for 1 more electron that would fit on that shell and only experience those 2 shielding electrons. So here there's this electron that's attracted to 3 protons and experiences 2 shielding electrons. Or this electron that's attracted to 9 protons and only experiences 2 shielding electrons. So the metal loses its electron to the non-metal, and once that happens, the metal is positive because it's lost something that's negative. And the non-metal is now negative because it has gained something that's negative. So now these two are attracted to each other, so they get close, and you have this positive-negative attraction. What about, we look at, let's see, so yeah, that showed us what happens between lithium and fluorine. Let's look at magnesium and fluorine. So magnesium has 12 protons, and it has 2 electrons in the first shell, 8 on the next shell, and its outer shell has 2 electrons. The fluorine, meanwhile, we saw has 2 electrons in the first shell and 7 electrons on the next shell. So it has space for 1. And then this guy, another fluorine. So I know this magnesium is likely to lose 2 electrons. Fluorine has space for 1, so it's going to gain 1 electron. And what happens is I'll use 2 fluorine atoms to gain the 2 electrons from the 1 magnesium. So this electron will go from here and end up here. And this one will go from here and it'll end up here. Okay, so now this has a 2+ charge because it lost 2 negative things, and this is negative and this is negative, and they stick together.